Hi everyone, so this is a review for Chapter 9 Revision Quiz, Set 1. So for our Google form, we received 26 responses, getting more and more disappointing. So since the responses is so disappointing, this is a new rule that I can make. If a question receives less than 10 people who ask for help, I will not do video for that question. Means by you need to have 10 or more students saying that you need help for that question, only I will make video for that question. In that case, only question 19 is qualified to be discussed for this set of questions. So let's move on to question 19. Question 19 says you have a pendulum which is swinging with an amplitude of pi over 3. Okay, it's a pendulum, then the amplitude, they say it's pi over 3. You should be able to relate it. This is in terms of radian. Okay, it's an angle measurement and has a period of capital T. If the amplitude is decreased to pi over 6, so you heard the word decrease, the angle decreased to pi over 6 radian. So what is the new period? New period, you can think of it as capital T prime. Okay, so the situation here is, let me zoom this out a little. The situation here is initially you have a pendulum swinging with amplitude of pi over 3 radian. Pi over 3 radian, if you convert it, it will be 180 divided by 3 degree. So it's 60 degree actually. So initially you have a pendulum swinging at 60 degree. Then the period at that moment was capital T. After that, through some transformation, your amplitude has decreased to pi over 6 radian. Okay, the new amplitude is pi over 6 radian, which if we calculate, it will be equals to 30 degree. So the amplitude of the oscillation of the pendulum decreases from 60 degree to 30 degree. Where is this 60 degree, 30 degree? Is actually from here. This is the angle that we are talking about. Okay, so it decreased from 60 degree to 30 degree. So they ask for the new period. New period, we can call it T prime. Okay, so actually for this question, it's wrongly made. I'm not supposed to ask you this question. There's a mistake with this question because for physics, right, if we are dealing with SHM right now, and for simple pendulum, only small oscillation can be considered as SHM. For simple pendulum, only oscillation with theta less than or equals to 10 degree can be approximated as SHM. If you go more than 10 degree, right, then we will not consider it as SHM. Okay, why? Because in your derivation, right, you apply something called the small angle approximation. Okay, what is small angle approximation? Basically, what you do is you treat sine theta to be almost the same as theta. So you substitute sine theta to be theta. You change sine theta to be theta. This only works if theta is small. Only works if theta is small. That's why it's called the small angle approximation. And because the derivation use something like this, so the derivation will only valid if the theta is about less than 10 degree. Which derivation I'm talking about? I'm actually talking about this derivation over here. T equals to 2 pi L over G, square root L over G. This is the derivation that I'm talking about. So actually, if I want to ask any question regarding simple pendulum, right, I should change the amplitude to be within 10 degrees. Okay, it probably can change from amplitude of 10 degree to 5 degree. Well, let's just do that. Okay, actually, let's just say that this is now no longer 60. This is amplitude of 10 degree decreases to amplitude of 5 degree. So what is the new period of the pendulum? Pause the video, think the answer. Okay, so for this question, the answer will be the period will not change. Why will the period not change? Because this is the equation that we are talking about when we are talking about period. So what can affect the period of the pendulum is only the length of the pendulum and also the acceleration due to gravity. Okay, acceleration due to gravity. So only these two quantities, only a change in these two kind of quantities can cause changes in the period of the simple pendulum. So for this case, if we reduce the amplitude, it doesn't change the length of pendulum, it doesn't change the acceleration due to gravity. In that case, your period will be constant. Therefore, the answer will be capital T. Okay, so that's the answer if I change this to become angle which is less than 10 degree. So now you may be asking, if it's more than 10 degree, then what happened? Well, it cannot be approximated as a simple harmonic motion. In that case, this will not be valid. This will not be valid. It will not be valid for oscillation more than 10 degree. Okay, so you might be thinking, then what's the equation to replace this equation? Okay, what equation can I replace for the period of the simple pendulum? Well, personally I don't know it as well, so I did a bit of Google search. So there's this large angle motion of a simple pendulum. So they try to derive the period for a simple pendulum that is oscillating with a large angle. And this is the equation for their period. Okay, it's a complicated equation, but if you want me to elaborate, this is really more than what I can do already. This is the 2 pi L over G that you learn. This T naught here is the period. This is the period that we are finding. This is the new period. This T naught here was the original period when the angle is small. Then it's represented by this power series here. Power series, I think you learned about it in geometric progression probably, I'm not sure. Okay, then this K here is actually sine theta over 2, if I'm not mistaken. This K here represents sine theta over 2. Well, it's out of your syllabus. Even I also never heard of this formula before. Okay, so with that said, we have finished question 19 and we are finished with chapter 9 revision quiz set 1. Thank you very much.